Hello and welcome to the Orbiter NASSP P23 tutorial, Program 23. This program is all about cislunar navigation. What does that mean? That is figuring out where exactly in the space between the Earth and the Moon you are. Now, the computer in the Apollo spacecraft knows where you were and where you were going at a specific time in the past. This is known as its state vector. It basically is a fixed point in time with a specific position and velocity. Heisenberg uncertainty principle be damned. I know, it doesn't apply at a macro level. I get it. And in theory, it can figure out where you are in that transitional space, that space between Earth and the Moon, to update state vector. But mathematical errors are introduced because the math model is not exactly identical to the real world model. The Earth is not perfectly a perfect sphere. And so the math on the way to the Moon is pretty good. But we can make it better by getting offset sightings and getting an exact distance from both the Earth and the Moon. So, to get into this tutorial, what do I have set up here? Well, what I have set up is a Apollo 8 mission shortly after TLI, and just before hitting record here, I uplinked a brand new state vector, loaded that into both CSM and LM state vectors. So right now, my computer has two good state vectors stored, and I did an IMU alignment. Literally just boom, boom, start record. So we're starting with a really, really good state vector and a good platform going into these P23s. That's important. The farther off either your state vector or your platform are, the more painful these P23s will get, and or the higher errors you're going to get. Now, the whole purpose of a P23, of course, is to refine that state vector. So there's a reason why they're done. And hopefully as you use this and do this process, you'll start to recognize where some of these P23s are actually helpful. But what's going to actually happen today is we're actually going to deviate our state vector because P23 is imprecise. So I'm going to do a couple of horizon marks. I'll talk about landmark marks, but they're honestly a bigger pain in the butt. And I'll talk about why when we get to that. But I'm going to demonstrate some some horizon marks, and I'm going to explain some of the theory behind the operation here and what's going on as we go. Fair warning for anyone who has not tried to do this already in NASSP and does not know about the flicker. The current implementation of these optics for P23 specifically has a pretty bad flicker it's bad, like full seizure flash warning here. When we get to that point, it's gonna flicker pretty bad. If that's something you can't handle, or if you've not tested it with NASSP yet, go ahead and continue and see whatever. The reality is, in NASSP, and even in the actual real missions that flew, P23 ended up being not that important. The reality is the purpose of it was to ensure that in the case of a catastrophic, loss of communications failure, where the astronauts have to do an abort all by themselves, that they could do it, right? So they would have had some information uplinked to them regularly throughout the mission about how to abort. These are known as abort pads or return to Earth pads, depending on when they happen. And so astronauts get this information regularly throughout the mission. And so they've got these thresholds where, hey, if everything goes wrong and we've lost all communications, the mission is scrubbed, we're coming home. Obviously a temperature diagnose and whatnot. But they've got these abilities to say, I guess we're going home, and scrub the mission. The commander always had that authority in a loss of communication scenario. And these abort pads and these P23s were about enabling that capability. As it turns out, loss of communication wasn't really a big issue. And the only scenario that ever led to a communication issue was a lot more serious than just lost communications. And it ended up crippling the entire CSM. And of course, I'm talking about Apollo 13. So, without further ado, let's do a mark. We're going to start with a mark that is actually from the Apollo 8 flight plan. It's supposed to be performed basically right now, at 4 hours and 20 minutes into the flight. So, we're right on time for it. And this is a Star 14 Earth Near Horizon mark. So, I'm going to go ahead and get into P23. As of course, with all programs, you enter it by verb 37, enter, program number, enter. And then we get right into a verb 5 noun 70 requesting input. This is asking for what we're marking. These registers will have junk data in them, depending on what you most recently did. And uplinks that have happened, etc. These registers are used for other things in different other programs. So we're just going to go ahead and replace all of them. These are octal registers. Register 1 is our star. So this is star 14. I don't need the leading zeros because it's an octal register. Register 2 is landmark. This is if you're looking for a specific point on the Earth or the Moon that you're going to be referencing against. Apollo 18 did a couple of landmark sightings. As far as I know, the landmark sightings were phased out pretty quickly throughout the Apollo program, as they turned out to be a little bit harder to do, apparently. But we're not doing a landmark here, we're doing a horizon, so we'll just put a 0 there. And then finally, this last register is 00 body which horizon 0. So this is Earth near, so it's 00. 1 for Earth, 1 for near, so that's 2 for Moon, and 2 for far. And then 0. Of course, I could have done just 110, but I wanted to spell out the whole register here because it's a multi-field register. Now, what is near and far horizon? Well, it all relies on the star body line. When you draw a line from the star to the body, so in this case from star 14 to Earth, and you look at the horizon, which horizon are you going to mark against? The one closer to the star, or the opposite one, the one on the other side of the planet? Why? Well, because one of them is going to be lit up by the sun, and one of them is not. And so depending on which star you're picking and where you are in space, decides whether near or far horizons are needed. Flight plans already tell you, you don't have to figure this out, but I will actually talk about how you can figure this out a little bit later. So we've got our entries. Hit enter one more time. All the registers fill in the leading zeros, and we can proceed. Now it's asking us if we want to auto maneuver the landmark line of sight to the horizon. And we do. So we're going to set spacecraft control CMC mode to auto. We're going to make sure that our auto RCS is configured correctly. Make sure your DAP is configured correctly if you haven't already done that. Which mine is configured right now for low bandwidth. And then you can pro. If you hit enter, you'll skip the auto maneuvering. We're going to pro. It's going to calculate. Alright, it has calculated a body. It's important to note, this auto maneuver could gimbal lock you. So you want to look at your pitch and your gimbal angles here, and make sure that it's not a pitch that's literally 180 degrees away from you and a close by yaw. Because if it's literally 180 degrees away, the auto maneuver could theoretically move through the gimbal lock area on accident. I think auto maneuver is supposed to be pretty good about that. I don't know the exact details. Later versions I know are better. I admit, I know I can do this one because we're about 30 degrees off. Yeah, 50 degrees off still. I'm going to gently time skip through this maneuver. And as we get close, I'm going to jump into our optics. And so you can see we're coming up to the Earth horizon. So landmark line of sight, I'm just going to throw out here, if your optics are zeroed, which mine are, then landmark line of sight is right there. And we're shooting a little bit past it. And we can correct for that. Now, how would you do this manually? Well, you'd acquire Earth. And then you take over control. And then there's a real trick here. This is what this 25 degree is really good for. So I've offset the telescope 25 degrees. Turn off the zero, but I'm leaving the trunnion. I'm going to rotate the telescope till I see my star 14. Now, I'm going to maneuver using min-impulse jets to bring the Earth horizon into this area. Right, so this is a 25 degree offset. Right, so now with the telescope trunnion at 25 degrees, landmark line of sight, or zero trunnion, is right here. 25 degrees is here, 50 degrees is here. This lets the telescope see the possible field of view of the sextant, right? Because your sextant can go from 0 to 50, and then you've got the full 360 rotation. And so now I go into my sextant view, and there's my Earth horizon roughly aligned with star 14. And I can go to medium and be a little bit more precise here. And I could see that actually I probably want to adjust my horizon a little bit because I'm a little bit high. Because it's really important to be on the tangent line, right? So the line that this is going through needs to be perpendicular to your tangent. Alternatively said, these two marks here need to be tangent to the horizon. Another way of saying that is to come in here and say that the line between this mark and this mark needs to be tangent to the horizon. So now that we've got the sextant, the Earth horizon in view in the sextant, we can get that pretty close. Of course, this could also be done with auto marking, or with auto optics, which I'll also demonstrate in a moment here. So I'm going to go ahead and freeze the horizon as much as I can. I'm going to go ahead and re-zero my marks, or my optics. Re-slaved it, so everything's back to where my landmark line of sight. I tell the computer I'm done with my auto maneuvering. Now it's asking me to mark with my landmark line of sight and star line of sight overlapping. In NASSP, that means Trunnion 0. That's it. Out in reality, there would be an ever so slight variation as, installation errors, thermal dynamics, etc. Even a slight variation in the geometry of the optics. We're talking like hundredths of a degree, or even thousandths of a degree, but they matter, right? So there's a routine here where you are aligning the two lines of sight, but right now in NASSP Perfect Optics, these lines of sight are always aligned at 0, so we can just hit mark. And it's happy, and it says, oh, you're using a bias of 0. Yes, we are, because we have perfect optics. Now, we can turn on the auto optics, hit Pro, and come in here and activate our dual line of sight. Apologize for the flickering. And so now it's going to align the star line of sight with the star. But we're also seeing the landmark line of sight superimposed. Now the flickering is because due to old orbiter limitations, this is actually done by switching every 2 frames. So it's a visual trick. You're actually seeing every 15 frames it swapping from one to the other. But then to mark, we simply take the control, put it in resolve mode so that you can do left, right, up, down, as opposed to if I do it in direct, that's up, that's down, that's left, that's right. That's not fun. We'll put it in resolve mode. Now I can do down, up, right, left, which they're backwards at the moment because honestly I'm not sure. It might be a case of I'm moving the optics to the right. I did know this. I was looking at that description earlier, but it's been a bit. Alright, so I want to put the star on the tangent line. On the horizon, on the tangent line. And I would say actually the tangent line is probably right about here. We're pretty good. And so I think we can go ahead and mark. So now it's saying, hey, you've marked. Are you happy with it? You can obviously mark reject to go back and resume marking, or you can say, yep, I'm happy with that one. I'll go ahead and re-zero the optics for later. Fun kind of effect there is that lines up. So the start line of sight and landmark line of sight realign. And then it says, hey, just double checking, what did you actually mark? I know what you planned to mark. What did you actually mark? Did you mark 14 on Earth near horizon? Yes, we did. So we can just pro. Otherwise, we could update this with verb 25 to say, no, I didn't. I marked star 16 or whatever. But we did mark 14 on Earth near horizon. So hit pro. Alright, and so now we have a error, or rather, how much we're changing the current state vector if we apply this. And that is to say, we are changing the state vector by 0.7 nautical miles, which is not much, actually, in the grand scheme of things and in the distances and scales we're talking about. And we're changing the state vector by 2 feet per second. That is to say, we're changing our understood position and current velocity by 0.7 nautical miles and 2 feet per second. This is honestly a pretty good mark. You're only going to get this low in numbers with a good mark and a good starting state vector. So if your mark is really good, but your state vector is bad, these numbers will be high. If your state vector is really good, but your marks were bad, these numbers will be high. It was considered acceptable to commit if both numbers were below 50.0, so 500 in the register. We are way below that, and unless it's been a long time since I've marked, I personally aim for single digit. So this, 2.0, 0.7, this is single digit. So I'm going to go ahead and accept that. And then we get our flashing verb 37 asking us what we want to do next. Do we want to go to program 0? Do we want to do another mark? Do we want to go wherever? It's asking us what program we want to run next. So I'm going to go ahead and run 23. I'm going to show you what the entries here look like for landmarks. I'm not going to bother trying to do a landmark mark. They're very hard to do in Orbiter unless you've got like a landmark that is a specific corner of a landmass. They're really hard to do in Orbiter. The graphics of Earth just aren't that great. And at the distances we're talking about, it's really hard. So I'm going to go far enough here to show you the input for a landmark. So we're going to say we are doing a landmark. So we'll say we're still doing star 14. We're doing a landmark on Earth. That's 100. 200 would be a landmark on the moon. And then, of course, we're not doing a horizon, so that's a 0. Then it asks for where's the landmark. And I'm going to grab a landmark from the Apollo 8 flight plan. No, those are horizons, those are horizons. Oh, come on. I know there's landmarks here somewhere. Here we go. So they did 2 on Earth Landmark 10 at about 9 hours into the mission. So this might not even be properly visible right now, but we'll see. So the entries here are latitude in 10.000. So this one is 28.876. Plus is north, minus is south. Longitude divided by 2, so 1/2 of longitude. Plus for east, minus for west. So the half of longitude for this, and these are all in your flight plans. 56.292. And then altitude for this one is 0.01. I believe that's in nautical miles. All right. Let it go ahead and calculate an auto maneuver. Now we might get a program alarm here. Oh, we didn't. Okay, so it did figure out a maneuver. Actually not very far away from our current orientation. So landmark 10 is supposed to be visible. I honestly was expecting a program alarm because it shouldn't... expecting it to not be visible right now. But I guess 5 hours from now is probably within visible range. Let's take a look and see what we see. Oh, yeah, it's close to the horizon, but it is visible. So the landmark is actually... let me actually... just point the sextant at it. So the landmark is, I believe, one of these islands in the Gulf here. So what we would do, we're going to say, okay, yep, that was a good one. We're going to enter past the 59 because we already did that. And it's saying, please mark. And we got an error because star 14 is out of range. Yep, 407 alarm, which means it can't reach the star in that we've asked for. So I won't be able to mark this one. We'll go ahead and key release and reset. Clears the error. So what I'll do is just to demonstrate, I'm going to stick... star 15. Oh, I'm in resolve. That's why it's driving so funky. No, wrong way. Alright, so what you would do, now going back into Resolve, is you stick the star on the landmark. And then you mark. And we can go ahead and mark, because we're just going to tell it we picked a different star. So now I'm going to Verb 21, we actually marked star 15. The landmark was still the same. And now it's going to calculate our angle. See what we get. Oh, you know what? Actually, that's not bad. That's a landmark line of sight. So there we go. A decent demo of a landmark marking as well. So you got a landmark P23 that I was not expecting to include in this video. So yeah, that's actually a very decent deviation. So I'm going to go ahead and accept that. And then I'm going to go ahead and go to program 0. Now normally you would do 2 or 3 marks at the same star and horizon, or same star and landmark, and follow the flight plan. The flight plan tells you, 2 marks, 3 marks, whatever. But if you're ever wondering, go to 0. If you're ever wondering, which horizon do I want? You put the trunnion to 25 degrees. Which it does not. Let me zero the optics. There we go. Telescope turning to 25 degrees. Oh, hush you. I know what that alarm is. I didn't leave it at 0 long enough. And you rotate it around your landmark, and that's going to show you what stars you can reach. Any star between 0 and 50 you can reach. You can mark with that, right? Or, let's say I want to do star 16, right? So I'm looking at star 16, and I want to know, can I do near or far horizon? Well, I can look at it now in the telescope and go, oh, well, near horizon, that's not a good horizon. That's a dark horizon. That's going to be really hard to see. So I'm going to do far horizon. And so that's what you're looking for, right? So when you're scanning around with the telescope, you don't want to have it, you don't want to like center it on the star. You want to center it offset 25 degrees with the 0 here on your planet, on your horizon that you're targeting. So now I'm looking at 15. 15 also would be ideal to do with the far horizon. And I could come over here, do just a little bit of pulsing, and get 15's far horizon lined up. How do I know? Because I've got the shaft axis running through star 15 and the horizon. It is running through the tangent line, nearly perpendicular. It's as close as I can eyeball in the telescope. And the horizon is at the 0 mark. So now I know I'm in a good spacecraft attitude to mark this. So then I want to look back at my sextant line of sight. Right? And then I can turn this back to slave to sextant. come back out here, and I'm going to zoom this up to Sirius. And there you go. So you can do all this manually. You don't need the computer to do the automatic alignment, but it sure is nice. Right? So then I could align over here, and I could mark if I was in P23. And then, of course, make sure you leave your spacecraft in a configuration that won't go into gimbal lock on you when you're not paying attention. My personal preference, at this point, I'm far enough from gimbal lock. I just throw deadband to max, rate to high, Vmags to @1 rate 2, and let the SCS keep me pointing roughly that away. Thank you for watching. I hope you learned something. I certainly learned a lot making this video, as anyone in the NASSP Discord can attest to, as boy were there a lot of conversations. A little bit of trivia. How is the dual line of sight actually handled? Well, it turns out that they were both sent through to the optics at all times, and there was a polarization applied to the landmark line of sight. A polarized filter inserted into the eyepiece could be rotated to reveal or hide the landmark line of sight. So they actually truly were superimposing those sights. Additionally, there was a dimming factor applied to the landmark line of sight, making it roughly 8 times dimmer than the star line of sight. So that helped balance the visibility of the star against the landmarks that were very brightly illuminated. Obviously, that detail isn't fully implemented in NASSP currently, and for the moment, the flickering is what we have to deal with. Of course, the inspiration for this video was me going, what the heck does that mean? So I went and dug, and I learned, and other people in the NASSP Discord dug better than I did and gave me the pieces that then we all put together, and we figured out how this all works. So maybe there will be a better version soon. But for now, this is how to do P23s. I'm Lasombra. Fly safe.